All right, so hey everybody, this is our last office hour before tomorrow's presentations. Today's agenda, just FYI, none of these things I'm expecting, like I don't need to see these in your projects for this phase. However, there's no other time to talk about this stuff, and this is something that you probably will want to implement or something similar to this for your capstone project. So the main things we're going to talk about is some of the beginning steps to productionalizing your model. So we've built models, we've trained models, great. We are able to build classification models. Even last phase, we did regression models, but how does that work outside of a Jupyter notebook? We haven't really gotten to that yet. And typically when you have a model, you want to be able to use it elsewhere. So I'm going to talk about just some of the beginning steps to being able to do that. So there are a couple steps to doing that. And I'm going to use like the same banknote prediction data set that we've been using throughout this phase. So first step, choose your final model. So let's just say that with this data set, I've decided that I want to use a random forest classifier. So I do my chain test split and I've got my confusion matrix, all of that looks good. Awesome, I know that this is the model that I want to use. And the model can also be a pipeline. So let's say this entire pipeline with a standard scalar and a classifier, that's what I want to use for whatever in the future. If you want to use other things like one hot encoder, if you basically any part of your pipeline, as long as you have a pipeline, you can actually save that entire pipeline. So cool. This is the final model I want to use for predicting banknotes, any like unseen banknotes that weren't part of my data set. I want to use this. What you want to do is you want to pickle this model. Now, pickling this model has a lot of benefits. Basically, it's sort of like saving your model, exactly the same thing as when you have your data frame and it's all clean and you don't want to have to re-clean your data. You can just to CSV the clean data frame. By the way, you all can do this with your projects as well, because I think a lot of you are doing a good bit of data cleaning. So with that, the syntax for pickling your model is just like this. It's just one nice line. So you're going to import pickle, and then you're going to do pickle.dump. And then how pickle.dump works is this is the object that you're going to pickle. So this pipeline is literally this pipeline object. And it's very, very important that before you pickle it, it has to at least go through the .fit step. So over here, we've already called .fit on the model. So you know that this pipeline object already has, all of the parameters saved to it. So here we're doing pickle.dump pipeline. And then here, what this is an open object, but main things you have to know is this is going to be the file name of your pickle of the model. And then WB actually stands for write bytes. So it stands for write bytes. So that's what the WB is. If I run this, and let me pull up my Jupyter home so you can see it was created. Over here, you can see that there's this new pickle object that was created seconds ago. So this model has successfully been saved. If you want to, do your final models and maybe you want to do a bunch of like feature importances, or maybe you want to do some additional analysis in a different notebook, you can actually pickle your model and open it in a different notebook. And I'm going to show you all how to open it next. But any questions about this pickling step? The main thing to remember is you have to have .fit your model first, because if you don't .fit and then you pickle it, if you try and make predictions using that model, it won't even know how to begin making predictions. Okay, so next, how do you make predictions on unseen data? Right. So far, we've really just been dealing with the data that we have, whether it's from the train set or the test set. What about just data that exists in the outside world that's different from the data that we have in our CSV file? So depending on what your data is, the pre-processing steps are going to be slightly different. But for this data set, we're going to start simple and I'll explain how you can apply this to other things. So this data set is fairly straightforward. We really only have 4 columns, and this is a .describe. So you can see that I have 4 columns of numbers. It has values in this range. So if we take a look at this, and actually I want to print out the head, x train.head. we took a look at this. This is just shuffled values of X chain. So in order to make some sort of prediction, I need to match these dimensions and just the dimensions of a single row. So let me actually rearrange this real quick. So if I do pipeline.predict, this is what we get. Let me get rid of that first. Pipeline.predict, and this will correspond to variance, skewness, kurtosis, and entropy. We get a prediction of 0. And just based on this data set, I believe 0 stands for, 0 is authentic, and then 1 is forged. I'll talk about that later. But this is how you can feed in any raw data into your model. The only thing we have to make sure is that the number of elements has to match the number of columns that you fed into your X chain. So what if you made like a bunch of dummy variables? So let's say you have a dummy variable that you've made into 20 different columns. You will have to write something that creates an array of 20. So for example, if you have something like, let's say you have 20 dummy variables, it would have to be 1 and then 0, 0, 0, 0, 19 times. So you would have to create that so that it matches, it corresponds to your X chain. However, you don't have to do this if you have one hot encoding. So because I'm using the pipeline here, any input data I feed in will also go through the pipeline. So therefore, this data that I'm feeding into, because in my pipeline, I have a standard scaler, the pipeline will actually do my scaling for me. So I don't have to pre-scale this data. So technically, I can give this prediction like a bunch of values from, let's see, this kurtosis goes up to 17. So I can make this like 16, for example. Looks like this has negative values as well. I can go like -8, so on and so forth. And I might get different predictions. Any questions on creating this? Depending on what your data is, the creation of this array might be different. And it is kind of case by case too, but just know that to verify that it's right, make sure that your X chain number of columns matches up with this as well. It has to be in the same order too. Okay, one other thing to note is see how here I have 2 sets of square brackets. This is kind of like a little quirk of scikit-learn and their .predict. But if I try to do the .predict with just one set of brackets, it'll give me a value error saying that they expected a 2D array, got a 1D array instead. And pretty much here it tells you what to do. Reshape your data either using this if your data has a single feature, or this if it contains a single sample. So in our case, we only have a single sample. We only have one row of data. So what you could do is do .reshape 1, -1. And oops, it has to be in NumPy array. P.array. There, reshape that. Without this reshape, you'll get that same value error. Or instead of adding the reshape, you can just turn this into a 2D array just by adding another set of square brackets, and that works fine. And if we take a look at the shape of this, this is 1, 4, one row with 4 columns versus doing something like this, where this is just a vector of 4. Cool. Anything to clarify here? Okay. So now that we know how the .predict function works, we can write a function to do it. And you should write a function to do it if you plan on productionalizing your model at any point. So here I'm taking in the model, and because I only have 4 features, I know y'all's will be more complicated than this, but because I only have 4 features, I can literally take in the 4 features as arguments, which is nice. So what I'm going to do here is I'm going to make a prediction, and we can see model.predict, blah, blah, blah. If it's 0, it's authentic, else it is forged. So once I define this, and if I call on this function, and remember that the model is the pipeline, whatever the inputs are, I can get either authentic or forged as an output. So here I have 1, 0, 1, 0. Let's say I have, I don't know what values I can put to get a forged banknote, but eventually you can get a forged banknote. Actually, let me look that up super quick of like what I can use to get forged. But any questions at this point? It looks like forge has mostly like negative values, so let's do that. Let's do, does this make it forged? Okay, there we go. So forged works as well. Any questions about this? Cool. Now remember that here, it really depends on this model object, what pre-processing steps you have to do. So if your scalar is outside of the model object, you would have to include the scalar in this function. So as an example, I have another, in one of my past projects, I'm going to pull up super quick. I hope it's here. There we go. I have this modeling function that pre-processes my text data. We haven't talked about text data yet, but same principles apply. Here, I'm just pre-processing my data before I run it through the predict, and my pre-processing steps are here. Right now, I don't think any of this makes sense to you all because it is text data, but some things that might look familiar, I'm doing like a dot transform. I have my pickles in here. Pickles are different, slightly different for NLP, but basically I have something that pre-processes my data into the exact format that I need for it to go into the dot predict. So it could be multiple functions that works as well. All right. So with this, you can pretty much, you can pretty much make any predictions on any unseen data. Any questions before I move on to the next level of stuff? All right, so this is still occurring within a Jupyter notebook. How do we get it to work outside of a Jupyter notebook? So for now, I'm actually going to show you how you can build like a command line tool. It is very, very quick to see how you can make predictions within your terminal. I'll change my share screen so you can see my terminal in a little bit. But first, you got to turn it into a script. So first, we can load our model. So just to show you all, I believe, okay, model's not defined yet, but I'm going to load up the pickle that I had before. So before I saved my pickle here and it's model.pkl, and model right now is undefined. So to load up the pickle, it's just pickle.load in contrast to pickle.dump. Pickle.load, it is opening the model pickle file, and RB stands for read the bytes. So once I run that, now you can see that my model, it actually returns a pipeline. So that pipeline was actually saved. And then I can actually throw in model into my make prediction function. So make prediction previously could only take in pipeline, but now I'm giving it model, and that works. Even if I give it these like negative numbers that it needs to be forged. There we go. This make prediction function works on this pickled model. So if I were to actually take this and put it to a different notebook, it should work as well. So now that we have this pickle open, let's take a look at a script. So this is this is the script that does run the model. So you have to make sure that you're first importing everything that you need. And then I'm literally just copying and pasting my make prediction function. And then what I'm doing here is I'm loading my model within my make prediction function. So everything else is the same. I'm making a prediction using these 4 features. It's going to return authentic or forged. At this point, any questions? Because I'm about to reshare my screen. Okay. Yes. So let me pull up. Hold on.
I had a quick question.
Oh, yeah, please go ahead.
Why wouldn't you put the original for the
Model?
Yeah, like pickle.dump. Why would
Oh, okay.
Scripting? Is this code just strictly for the scripting? Is this like a way to transform it into a script? I don't know if that makes sense.
Gotcha. So here I'm actually loading the model too, because what I want is I want to be able to reuse the exact same model that I used over here. So pickle.dump is just to save a model. And so for all future things, because I know that that's my final model, I want to use that specific model over and over again. I do not want to retrain my random forest every time I want to make a prediction. So therefore, even though here I'm saving the model, and this is where I'm saving it, everywhere else, I'm just going to open up the model. Does that make
Okay.
sense?
Yeah,
Yeah.
that makes.
All right, so here, I'm just taking this step and putting it into this function here so that it's always using the right model object. So that's why here, everything else is the same. Like these lines are all the same as the function in the notebook. The only difference is now I'm loading the model.
Yeah. All right. Thank you.
You're welcome. Okay, let me reshare my screen now. Which is it? Okay, here. Okay, so this is my terminal, and my terminal is already in the place where it is where this notebook is. So if I do a quick ls, you can see that I have, these are my notebooks, and then also I called this banknode pred.py, and so that is here. So one really quick way you can test to see whether it works to be productionalized is by running Python and running your function through command line. And so it does depend on which version of Python you're using through your command line. I have changed it such that mine only recognizes Python 3. If I do Python, it doesn't work, but basically I'll show you what happens later. But for terminal, I do Python 3 -i just means interactive, and then run the script. So banknote pred.py. When I run that, what it's going to do, it's actually going to run the entire script. So what that means is it's executing this whole thing. So it has imported all of these, and it's also defined my function. And as you can see here, these 3 arrows in Mac terminal just means that it is currently in Python. So if I run this thing, this is also, because this is Python, I can pretty much do anything I would do in a Jupyter Notebook cell. I can do math, I can do, I don't know what else, more complicated math. Oh, I could do like a sum of like 1, 2, 3. That works too. So you can actually run Python like this. As long as you do Python 3-i, it allows you to interact with Python in your terminal, which is pretty neat. It works for Git bash as well. This just means that it's executing this particular file. So because this has already been executed, I can actually use my make prediction function here. So really quickly, if I do make prediction, and here you can see I actually got rid of the model argument because I always want to use this specific model. So all I have to do is give it 4 values of something. So let's give it 4 values of something. Let's do like -10, -10, I don't know, 6 and 8. And you can see it returns forged. If I do make prediction again, and we'll do like, I don't know, 0, 0, 0, 0. That's forged. Oh, cool. That's forged too. I think if I do 0, 1, 0, 1, I just want to show an example where it's authentic. Damn. All right, let's see one more. Okay, great. I thought it was broken for a bit. Okay, so from this is one way to check whether this will be able to be productionalized. Because right now, all this is calling is this thing. It is not calling on anything that you've defined in your notebook. So therefore, and I'll talk about this more when we get to the capstone, but if you can get to this stage, you're pretty much ready to get your model into production. And then when we get to capstones, I'll talk more about building like a front end out, how you can build like a little interface to use your model. But for now, if you can get this to work, it's a really, really good place to be. Again, I don't need to see this for this project. I do expect a lot of you to like come back to this when you're working on your capstone. So no pressure to do this right now. If you have the extra time, sure. The beginning of phase 4 is a little bit slower to start. But just so you know, this is step 1 to productionalizing the model. Awesome. With this, does anyone have any questions? I know this is not super relevant for right now, so feel free to let me know if you have questions about this anytime in the future.
Is this more for like people who want to use, like if you're have a job and you make a model and let's say someone's trying to figure out if this is fake or not based off certain values, so anybody else can use it without being technically an expert, or is this something like they're expected to do for every model that you make? Generally.
Okay, in general, I would say, so let's say I work for a fraud company and they actually want And let's say this company, and I'm trying to think of an example for this, and let's say this company wants to like have it such that, okay, I don't know if this banknote is real or fake. Maybe I can like input some values into my company's phone app, and then based on that, I can use this model to figure out whether it's real or fake. So productionalizing is just utilizing your model outside of outside of like a testing environment. So Jupyter Notebook is usually like a testing environment or more for like analysis. Whereas this is to actually make use of your model out in the real world. So usually if you're building something something that has a main purpose of making predictions, you would want to do a step like this, or like a recommendation engine. Otherwise, if you're doing something that's more for inference, like I know for those of you who are working on like the Terry stops data set, or if you just want to learn about your data through modeling, you might not have to do this step.
Got it. Thank you.
You're welcome. Anything else?
I have a question. So it seems like you'll be able to kind of like, let's say I like every week I get a new set of data. It seems like you can probably write it so that it opens up like a certain named CSV file. If you put it in a folder, run it through and then have it spit out a new CSV with the results. And then like outside of it, I just kind of grab that data, move it out. And then next week I kind of go back in. So is that something that's actually feasible or?
Yeah, definitely. So there's this thing called Cron Jobs. I personally have never worked with Cron Jobs, so I've never needed to. But Cron Jobs is something that you can actually set up, and you can actually it's basically programming your computer to run things at like certain periods or intervals of time, or like at certain dates and times. And you can actually tell your terminal, be like, all right, every Friday, grab this new data from whatever API, for example, run it through my prediction function, get these results and see how it is. And the only way that you can get it to work with a cron job, I believe, is I believe you have to turn it into a script like this. And as long as it's executable using your command line, that's usually a good, safe, like first step. Sometimes you need to have other applications that connect with it too. But for the most part, if you can get this part working, generally it's enough, especially if you know you're not going to have to interact with like other parts. If there are no other parts to the puzzle, this should work.
Gotcha. I understand. Thank you.
No worries. Anyone else? All right. Well, in that case, I will stop the recording here, and I'm happy to answer any project questions since I know your presentations are tomorrow. So let me stop it here.